Now, how do we calculate Young's shear and bulk modulus? So first, let's see how to calculate Young's modulus. So just like the normal elastic modulus, Young's modulus Y is defined as stress over strain. So the stress applied, or rather the force applied, should be perpendicular to the area over the area, and then its strain will be the change in length delta L over the initial length. So you can also write this as over A times L naught over delta L. So next is the shear modulus. So the shear modulus it can be named with variable S. So we just like the normal modulus, we have stress over strain. But now the force applied is parallel to the area over the strain of the object. Now the strain of the object is tricky in shear modulus. So what is this quantity X and what is this quantity H? So if we would go back to the figure here, this X is this length. So this length should be parallel to the force applied. The forces applied. Now the H is the original length in the perpendicular direction to the force. So this is H. So as we can see, for example, if this object were to be very sheared, so for example like this, so it will have a very large amount, very high value for X, and our strain will be very large. So recall the strain in a shearing force is defined as X over H. So if this X is fixed and this is large, our strain will be large for the shearing moduli. So we can also write this as S equals perpendicular over A times H over X. So last, we have the bulk moduli. So for the bulk moduli, this is also defined as stress over strain. But our stress is the whole force applied over the whole area. So you can also think of this as pressure. So the strain or the deformation is just a delta V over the original volume. So for the bulk moduli, we have actually the pressure applied on the object over delta V naught.